In the world of computer networks, data packets travel through various routers to reach their destinations. These routers need to know the best path to forward these packets. This is where routing comes into play. There are two main types of routing: dynamic routing and static routing. This essay will delve into the concept of static routing, exploring its workings, advantages, disadvantages, and relevance in today's networking landscape. Static routing, as the name suggests, involves manually defining the routing paths within a network. This means that network administrators specify exactly which path a data packet should take to reach a particular destination network. This is in contrast to dynamic routing, where routers automatically learn and update routing information by communicating with each other. Imagine you have a small office with a single router connecting your devices to the internet. You might want to set up a static route to direct all traffic for a specific website through a virtual private network, or VPN, for enhanced security. This static route tells the router to send any data destined for that website through the VPN tunnel instead of the default internet gateway. Static routing might seem straightforward, but it involves understanding its characteristics, benefits, and drawbacks, which will be further explored in the following sections. Static routing is a routing technique where network administrators manually configure routing paths for network traffic. This means that instead of routers dynamically learning the network topology and making routing decisions on the fly, the paths are predetermined and fixed. One of the key characteristics of static routing is its simplicity. Since routes are manually configured, they are easy to understand and troubleshoot. The routing table, which stores information about available routes, is relatively small and straightforward in a statically routed network. Another important characteristic is that static routing doesn't require any routing protocols. Dynamic routing protocols, on the other hand, consume bandwidth and processing power on routers as they exchange routing updates. Static routing eliminates this overhead, making it very efficient in terms of resource utilization. However, the simplicity of static routing comes at the cost of flexibility. Once a static route is configured, it remains fixed until manually changed. This can be problematic in dynamic network environments where the network topology changes frequently. Despite its limitations, static routing remains a valuable tool in a network administrator's toolkit, especially in specific scenarios where its advantages outweigh its drawbacks. This essay will further elaborate on these use cases and demonstrate the enduring relevance of static routing in modern networking. To understand how static routing works, let's break down the process into manageable steps. When a router receives a data packet, it first checks its routing table. The routing table is like a map for the router. It lists network destinations and the best paths to reach them. In a statically routed environment, these entries in the routing table are manually configured by the administrator. Each static route entry consists of crucial information. This information includes the destination network address, the subnet mask, the next hop IP address or gateway, and the outgoing interface. The destination network address and subnet mask define the network that the route points to. The next hop IP address specifies the IP address of the next router in the path towards the destination. The outgoing interface tells the router which physical or virtual connection to use for forwarding the packet. Consider a simple example. You have two routers, router A and router B, each connected to different networks. To allow communication between these networks, you would configure a static route on each router. On router A, you would add a static route that points to the network connected to router B, specifying router B's IP address as the next hop. Similarly, on router B, you would add a static route pointing to the network behind router A, with router A's IP address as the next hop. This way, when a device connected to router A sends a packet to a device on router B's network, router A checks its routing table, finds the matching static route, and forwards the packet to router B. This process ensures that data flows correctly between the two networks, even though the routing path is predefined and not dynamically learned. Static routing offers several advantages. First, it provides better security because routes are manually configured and not advertised over the network. Second, it reduces CPU and memory usage on routers since it doesn't require complex algorithms for route calculation. Third, it ensures predictability and stability as the routes do not change unless manually updated. And finally, it's relatively simple to implement in small, stable networks. However, static routing comes with its own set of disadvantages. One major drawback is the lack of scalability. As the network grows, manually updating routes becomes cumbersome and prone to errors. Another issue is the lack of automatic failover. If a link goes down, static routes won't automatically reroute traffic, leading to potential downtime. Additionally, it requires significant administrative overhead, especially in dynamic or large networks, and it doesn't adapt well to network changes, making it less flexible compared to dynamic routing. So, when should you use static routing? It's ideal for small, stable networks where changes are infrequent. It's also useful for specific scenarios like routing to a stub network or for security purposes where you want to control the exact path of the data. In conclusion, while static routing offers simplicity and security, it's important to weigh these benefits against its limitations in scalability and flexibility. Understanding both the advantages and disadvantages will help you make an informed decision about when to implement static routing in your network. Sign up for InVideo AI through below referral link and get an exclusive bonus 50 AI minutes. Also, please let us know in the comments if you have a suggestion for our next video, and if you enjoyed this video and want to see more content like this. Make sure to hit that like button and don't forget to subscribe our channel so that you won't miss any of our future videos.